Hi viewers, welcome to the next section of the course, Basic Thread Synchronization. This section presents a number of videos that will teach you how to use the two basic synchronization mechanisms offered by the Java language, that is the Synchronized Keyword and the lock interface and its implementations. You'll have to implement all the programs using Ellipse IDE. You can also use different IDEs such as NetBeans, etc. Now we move on to the first video of this section that deals with synchronizing a method. In this video we'll learn the most basic methods of synchronization in Java, and also to use the synchronized keyword with sensor. Most of the basic methods of synchronization in Java are the uses of the synchronized keyword. It's used to control concurrent access to a method or a block of code. All the synchronized sentences use an object reference. Only one thread can execute a method or block of code protected by the same object reference. Static methods have a different behavior. Only one execution thread will have access to one of the static methods declared with the synchronized keyword. But a different thread can access other non-static methods of an object of that class. You have to be very careful with this point because two threads can access two different synchronized methods if one is static and the other is not. If both methods change the same data, you can have data inconsistency errors. In this case, the object reference used is the class object. Let's try to understand this with an example. Here we're implementing an application simulating a parking area with sensors that detect the scenario. When a car or motorcycle enters or goes out of the parking area, an object to store the statistics of the vehicles being parked, and a mechanism to control cash flow. Now we'll implement the scenario in our program with two versions, that one is without any synchronization mechanisms, and the other that works correctly by using two variants of the synchronized keyword. We create a new Java project. Perform these steps to implement the program. First, create the application without using any synchronization mechanism. So, let's create a class named as Parking Cash. This class contains an internal constant named as cost. Also contains the attribute to store the total amount of money earned by providing this parking service. With this line of code, we're specifying its initial value as 0. Now, implement vehiclePay method using this code snippet. This method is called when a vehicle, like a car or motorcycle, leaves the parking area. It will increase the cash attribute. Finally, implement the close method with this block of code. This method writes the value of the cash attribute in the console and reinitializes it to 0. You can see that the cash value is brought to 0. Create a new class and name it as ParkingStats. The class consists of 3 private attributes. Then, create the constructor with this line of code and initialize the attributes. Then, implement the methods using this code snippet. Here we are implementing the method when a car or motorcycle enters or leaves the parking area. When a vehicle leaves the parking area, cash should be incremented. Finally, we're implementing 2 methods by using this line of code. These methods are used to obtain the number of cars and motorcycles in the parking area. Let's create another class named as Sensor. This class will simulate the movement of vehicles in the parking area. With this line of code, we declare that this class implements the runnable interface. Before we proceed with further procedures, let's import the required Java library, that is Java Util Concurrent Time Unit. The time unit is an enumeration that includes days, hours, microseconds, milliseconds, minutes, nanoseconds, and seconds. These indicate the units of time we pass to the sleep method. Now we're adding this code within the sensor class. Using this code, we define the ParkingStats attribute, which we have initialized in the constructor. Next, we implement the run method with this block of code. In this method, we simulate that these 2 cars and a motorcycle arrive in and then leave the parking area. Every sensor will perform this action for 10 times according to the loop, specified in this line of code. In our case, we let the thread sleep for 50 milliseconds. Finally, we implement the main method. For that, we create a new class and name it as main. Then import all the classes that we created in the project. Those are parking cache, parking stats, and the sensor class. Now, proceed further with the main class, applying the main method with this line of code. This class needs parking cache and parking stats objects to manage the parking. This code creates the object for parking cache, and this code creates the object for parking stats. We create the sensor tasks by using this code snippet. In this code, we use the available processors method that returns the number of available processors to the JVM, which normally is equal to the number of cores in the processor. To calculate the number of sensors our parking area will have, here we create the corresponding thread objects and store them in an array. Adding this block of code, we wait for the finalization of the threads using the join method. Finally, we enter this block of code to write the statistics of parking. This code will initiate the close method. Now run the program and view the results in the console window. When you execute this program, each time you'll obtain different results, and most of them will be incorrect. In our case, we executed the program in a 2-core processor, so we will have 4 sensor tasks. Each task performs 10 iterations, and in each iteration, 1 vehicle enters the parking area, and none of the vehicles go out. In the previously executed program, we experienced race conditions, and the different shared variables accessed by all the threads gave incorrect results. So, let's modify the code using the Synchronized Keyword to solve these problems. First, we navigate to the parking cache class and add the Synchronized Keyword to the vehiclePay method. If 2 or more sensor tasks call this method at the same time, only one will execute it and the rest will wait for their turn. Therefore, the final amount will always be correct. Then, we add a synchronized block of code using this keyword to the close method. Now we navigate to parking stats class. Here, we add 2 new attributes. After that, we initialize both the attributes in the constructor of the class by adding this code. Finally, we modify the methods that increment and decrement the number of cars and motorcycles, including the synchronized keyword. So, navigate to the parking stats class and modify the methods. Here, the number of cars attribute will be protected by the control cars object. Also, the number of motorcycles attribute will be protected by the control motorcycles object. We also synchronize the getNumberCars and getNumberMotorcycles methods with the associated reference object. Using the synchronized keyword, we can guarantee correct access to shared data in concurrent applications. Execute the program and see the difference when compared to the previous version. You can view the output of the new version of the program. No matter how many times you execute it, you'll always obtain the correct result. You'll get the final stats as there are no cars in the parking area, which means that all the vehicles that came into the parking area have moved out. 4 sensor tasks were executed, where each task simulated 30 vehicles, and each vehicle was charged $2 each. Therefore, the total amount of cash earned was $240. In this video, we synchronized a method along with a sensor.